Hi everyone, welcome to Code Type Management. This is the part 3 of the Stream API under the Java 8 features. So here I will discuss about the stream intermediate operations. So you all know, right? So there are three parts for the stream pipeline. The first one is the source, second one is the stream intermediate operations, and third one is stream terminal operations. So here we will properly discuss according to the intermediate operations. So first one is filter. So just see the method signature of it. First is stream T means input is there, then filter, then predicate, super T, predicate. In this way, we can denote the filter. So when we will use the filter? So basically, if you want to return a stream from another stream that satisfies a given condition, then we use the filter for that condition. Suppose you have a sets of data. Suppose there are 11 strings or 11 data is there. And according to the business logic, you need to return some specific things or specific strings from them. Like you need to return the names which have this character, any specific character. So for that case, you can use filter. Suppose a sets of students is there whose ages are in between, suppose 20 to 24, and you have to return the students whose age is greater than 22. Okay, so for that case, you also use the filter. So for filtration process, according to the business logic, you will use that intermediate operation. So I am giving you one example, like suppose some strings are there, animal name are there, like lion, cat, monkey, cow, horse, and you need to return the name of those animals which have C in their first letter. So for that case, you can use in this way, like this stream string S equals this stream dot of, and these strings will be taken as lion, cat, monkey, cow, horse. And then you will use the filter method. So there you will check this starts with this C uh, alphabet. So you will do that x dot start with C. Then it will check all the strings and it will return those strings which first letter starts with C. So then we have used this terminal operation. The filter is the intermediate operation and for each is the terminal operation. And through this, it will print the outputs. Okay. So here, among this lion, cat, monkey, cow, horse, only cat and cow have the first letter C. So it returns the cat and cow. So it will filter from the whole strings and it will return according to the business logic that X starts with C. And through this for each, it will check all the streams, means it will return one stream, and from that it will print one by one. One is cat, then second is cow. So this is the methodology for that. After that, distinct. This is another intermediate operation. So it's you can say that method signature is like stream T, then distinct. So when we will use that? So if you want to return a stream from another stream with duplicate values removed, the unique values you need to return, in that case, you will use this distinct operation. Okay. So like here I am passing this cat, cat, monkey, cow, cat. So from these strings, it will return through the distinct the unique elements like cat, then monkey, then cow. So it's very easy process to return this kind of thing. So simply you will do this stream string s equals to stream dot of, then you will pass all the strings. Then from them it will means it will take the unique elements or unique strings, and then through the for each means through these terminal operations you will print the proper outputs. Okay, then limit and skip. So basically the method signature for limit is this one, like stream uh, stream t limit, then int max size, and then stream t skip int n. Okay, so this is for limit, this is for skip. So when we will use this, so if you want to make your stream smaller, and also if you want to make a finite stream out of an infinite stream, so for that case you can use limit and skip. So I'm giving you one example, like as and also I'm telling like these two methods means these limit and skip, these two methods have a common characteristics, like we will use them in a single example. So using the stream API in Java 8, we can use any number of intermediate operations in stream, right? So for that reason, we can use this limit and skip in the same stream example, right? So in this example, like I will want to skip the first 9 numbers, okay? And I have started, means I have iterated from I, and it will do like n plus 1, means 1 incremented through this. Then I want to do like I will skip the first 9 integers, and then I will return the rest elements. But this through this limit 6, I will make the series infinite from the infinite, okay, and then I will return only 6 integers after 9, right? So it will first of all through this it will return like 1 2 3 4 5 6 7 8 9 10. In this way it will give us the infinite stream, okay, and from that first through this skip 9, it will skip the first 9, means 1 2 3 4 5 6 7 8 9, it will be skipped, and then the rest means from the rest like 10 to infinite, then from that sets it will do the limit of first 6. So 10 is first one, then 11, then 12, then 13, then 14, then 15. So these are the 6 numbers, and here through the for each it will printing this 10 to 15, this 6. Okay, clear? After that, map versus flat map. So basically the method signatures you can see here, this r stream r, then map function super t extend r mapper, and here this way. So these are the method signatures. So when you will use this map and flat map, so basically if you want to transform the elements of a stream in some way, like if you want to transform each element into a single value, then you will use the map. And if you want to transform each element to multiple values, and also if you want to compress or flatten the resulting stream, then in that case you can use the flat map. And also map basically is used when you want a one-to-one transformation where each input element is mapped to exactly one output element. So I'm writing here 1 to 1. transformation. And also, the result of map is a stream of values, not a stream of streams. Okay, so output is also, it will return the stream of values. Okay, and through the flat map, you basically do uh, from one you will return a stream, not the values. So when each element in the input stream can be mapped to 0, 1, or multiple elements in the output stream, then it's specifically useful when you have a stream of collections or a stream of streams and you want to flatten it into a single stream. Okay, so for that case, you will use the flat map. Okay, so here output stream and input also can be stream of collections or stream of streams, right? And you want to flatten it into a single stream. So I'm writing the output here. Okay, output single stream. So for that case, you will use the flat map. So uh, if you want to know about some specific points, then I will say, like, for map, it basically works on stream of values. It performs the only transformation and it produces single value for each input value. Okay, but in case of flat map, basically it works on a stream of values and it performs transformation as well as flattening. Okay, for map only transformation, but flat map transformation as well as flattening, and also it produces multiple values. Okay, for each input value it will make or produce multiple values. Okay, so I'm giving you one example, like let's assume a list of programmers are there. Okay, and programmer consists of two fields. One is its name and another is its known skills, right? So one is name, another is known skills. So skills is set of or a list of strings. Okay, so then I have taken this programmer class. Then two fields are there, both are private. Okay, so name and skills. Then you can make the getter, setters, and all constructor, nowhere constructor you can also make. Then after that, I'm taking, or you can say as making some list of programmers. So there, this is the list of the new programmer. The first programmer's name is programmer 1 and its skills are like Java, Python, Angular. The second is programmer 2. Lists means skills are Ruby, Angular, Java. The third programmer there is programmer 3 and this list of means skills are React, Spring, then Angular, right? So suppose we have to extract the name of each programmer. Then in this case, we can do by using map method. Okay, so when some business logic or business requirement is like that, extract the name of all programmers using the stream API in Java. So in this case, you can use the map. Okay, so this list name is list of programmers. So from that you will make this stream, and from that you will use this map method. Then programmer is your class, right? So through this whole class, through the get name means when you will make these getters, so you will see the get name method. So now you will do here the method interface. Okay. uh, then after that you will collect those list from the mapping, and then you will obviously print through this for each, right? So this is the process, and you will get the output after applying map, like programmer 1, programmer 2, programmer 3, means these three names. Okay. And when suppose the requirement is like you need to extract some distinct skills out of all programmers, not all the skills, only the distinct skills like Java, then Python, then Angular, then Ruby, then it will be not, as it's already taken, right? Then React, then Spring, in this way. So for that case, you will have to use the flatMap. So here you will first take this list, so list of programmers, then stream, then you will use the flat map, and there you will do the flattening, or you will make so another stream through this, like through this get skills method. So you will make that streams again, and it will do like flattening from that, and then you will collect, then it you will use these two set, and you know, right, through these two set it will make the list as distinct or unique. So then you will get all the collections, means the proper unique list, and then obviously you will print through this for each. Okay, so this is the process here. So then first of all you will do the flattening, and then how you will do the flattening according to the skills. So you will make the stream, then from that you will collect that data from that in this pipeline, and then you will make some unique things like the distinct skills you will take, and then the resultant list you will print through this for each system out println, and this unique skills will be printed here, right? So this is the map and flat map case, and after that sorted. So these are the method signature for that. So when you will use this sorted, so basically when you need to return a stream with the elements sorted, okay, like sorting arrays. So Java uses natural ordering unless we specify a comparator. So through the comparator, we can specify. Okay. Otherwise, it will just do some natural ordering, right? So so using this first method signature, means this one, it will make the default order, and through this second one, means this one, okay, it allows us to pass a comparator and sort the stream as per the business requirement. Okay, so like this is the stream of strings. You are taking the name of the days of a week, like Sunday, Monday, Wednesday, Thursday, and then you are sorting these strings through this sorted method, and then you are just printing. Then it will basically return according to the default order. So Friday, Monday, Sunday, Wednesday, in this way only. And if you want to specify the reverse order, then you need to pass the comparator inside this sorted method. Then you will do like sorted, then you will use comparator, then reverse order. Then through this for each, you will just print the reverse order of that strings, right? So it will print the reverse of this. So Wednesday, Sunday, Monday, Friday, in this way. Okay, so next one is pick. So pick, for that the method signature is like that. So when you will use this pick, so sometimes we need to perform some operations on each element of the stream before any terminal operations is applied. So basically this peak performs the specified operation on each element of the stream and returns a new stream that we can further use. Okay, so it is useful for debugging because it allows us to perform a stream operation without actually changing the stream. Okay, so the most common use for peak is to output the contents of the stream before any terminal operation is applied, right? So I'm using one triple divisible by 2 sum, this method, and there will be one start, one end. Okay, so we basically use this peak to get the output before it will pass to the terminal operation to check properly that our intermediate operations worked properly or not. So for this debugging case, we will mainly use. So first peak, it will print the original element, right? Then, so it will print the value before multiplying by 3. So suppose one input you are giving, that will be printed here. So after that, you are using map. So through this map means 1 to 1. So 1 by 1 to 1, you will just multiplying it by 3. Then after that, through this peak, you will print the value after multiplying by 3 and before filtering. So it will give you the output. After that, filter. So through this filter, it will give you that those are like divisible by 2 or not, means order even, you can check. And after that, it will print the value after filtering, but before this sum operation, right? Okay, so if we call the above method passing the parameter as 10, 15, so our starting is 10 and ending with 15. So first of all, the original element it will print as 10, then the tripled element will be printed like 10 into 3 is 30, then divisible by 2 element. Okay, so it will filter and it will check that it's 0 or not. So it's 0, right? So divisible by 2 element. So it's as it is divisible by 2, so it will be printed. So 30 is printed here, right? Then after that, the next element is 11. So 11 is the original element, tripled element is 33, and it's not divisible by 2. So 33 is not printed as divisible by 2. So next one is 12, then tripled is 36, and it's divisible by 2. So 36 printed. Next is 13. So original is 13, tripled element is 39. So it's not divisible by 2, so it's not printed. Next is 14. So for tripled element of 14 is 42 and it is divisible by 2. So 42 is printed. And after that 15 and tripled element is 45, but it's not divisible by 2. So 45 not printed. So that's all for now. So in the next lecture, we will discuss about the terminal operations. Okay, how to do the terminal operations in the Stream API. So till that, uh, just to like, share, subscribe as much as possible. If you have any questions, then you can comment in the comment section.